So thank you all to the speakers for the fantastic presentations. And now we will open the floor for questions. So please feel free to ask any of our panelists about their presentations.
Brian Nahas with Mortensen. Probably directed more at Hensel Phelps and DPR. Curious on the scopes where it's not self-perform, but you're facilitating composite layout. How have you navigated contractual expectations of your trade partners?
I can start. I think that's a great question. So if you're self-performing the layout, how do you deal with the trade partners? So the way we work is there is so much benefit in having robotic layout. So what we do is we will self-perform the layout. We'll lay out your full your MEP and mechanical, electrical, all the trades, and then we'll tell the trade partner all you have to do is come and QC a few points. So it saves them labor because instead of having their labor doing all the work and it's a lot of physical labor, they just have to QC it. So they still have the liability is still on them. So that's how we have worked so far.
Yeah, I'd say it's fairly similar. It definitely changed over the course of when we were first trying things out, right? Again, like one of the points about finding the right jobs with the right scenarios, the right environment, right? Sometimes you have other subcontractors who aren't a part of our self-perform group and trying to find the ones who are, again, like open to trying new things. And so got to find that openness first. But as it developed over time, more the contractual kind of protect yourself type of scenario, it does turn into more of, okay, this is where we're planning to do a multi-trade layout. We need everybody's files in here. We're getting coordinated, all of that. But it's going to be provided, I guess, kind of like a service. However, we're not taking on the liability of like each trade still needs to come in and QC everything that has been done to make sure that nothing. You don't need to like raise your hand to say like, hey, my stuff's not right.
And just to add, you might face some resistance in the beginning, but as the trades understand the value of it, everyone will eventually get aligned.
Hi, I'm Kapil. I work for Exponent as construction consultant. Adding to his question on the self-performing layout, have you ever witnessed that based on the quality check, if the results are not good, that adds to the effort of the laborers? And that might add frustration and less adoption of technology. So have you ever witnessed that thing? And how do you make sure that the crew is still excited to use that robots on site?
I'd say with robotics, they're just advanced tools. I don't really like to call them robots, it's just advanced, smarter tools. And in just as time progresses, we'll have more and more of these smarter toll station, for example, control tools come in the workforce. So there needs to be some education on how these tools work, just like we did today with the toll station. If your control points are off, your whole layout is going to be off. So a lot of times, if something goes wrong, it's because they are not following the best practices. But once you explain it to them, and again, they see the advantages. One of the great advantage of the layout robotics is you coordinate with all of the trades and lay out all of the trades at once. Now you can take all your trades, mechanical, electrical, and you can walk the field. And you can see, there's my electrical fixture, and there's framing that's going to go in the same place. And now you can fix that before you install it. So I'd say once you kind of demonstrate the advantages and the benefits, they'll be much more likely to get on it.
Yeah. Just wanted to add a comment, not from a GC perspective, obviously more from a robotics kind of philosophical perspective. There is a little bit of scare, or frightening from local jurisdictions where there is unions, for example, where people are like, hey, you're stealing my job, or you're taking my job. And this is, historically has happened also in the, manufacturing, let's say, world, or in the agricultural world, where there was the exact same fear, and then ultimately, humans will still always, at least in the near future, be needed. Perhaps maybe the skill set will be different. So the implications for general contractors or local inspector community and things like that are more about what kinds of people do you need and what kind of skill set do these people need, and how can we train them to essentially cooperate and collaborate with the robotics side of the tasks. But to your point, a lot of the situation is that in some of the jurisdictions where there is union labor, there is a kind of underlying fear that robotics will take over. And I think that this is not something that should hold us back. In fact, again, looking at other industries where this has been super successful, like agriculture or manufacturing, we can learn that actually that's not a fear that makes too much sense, essentially.
Yeah, and when it comes to just the selling the other subcontractors or the trades on adopting kind of like a get it all laid out in one pass type of approach, part of it is the kind of like I don't know what you'd call it. Like when you show up to a site and it's like the informational onboarding. There's a lot of people in the room who are going to be like seeing this for the first time or thinking about it for the first time. Other folks who may already have experience, and I think being able to kind of like guide them through the process of like, we've done this before, here's the steps that worked well, and just again sharing those lessons learned. And because oftentimes when it comes to even when specific trade by trade, even just when it comes to how do they do their layout, a lot of folks have very different approaches. And so being able to kind of paint that picture and then show them how, okay, like on a traditional job site where let's say you've got a carpenter who's coming out and they're pulling tape measure off of chalk control lines in a building, and then you've got, the electrician coming in, they've got their Trimble total station, and they've got a prism rod dropping their points. You're almost kind of coming at everybody's layout from different directions, which, may or may not align to the same thing at the end of the day. Or if somebody, overlooks something, some detail, and maybe piggybacks off of somebody else's layout, where you don't know if that person prior to you actually laid out their lines slightly off, right? Maybe it wasn't 100% accurate. You have these compounding issues that could really bite you later down the road. So being able to kind of align around the approach and get everybody kind of understanding how these processes come together and being able to sell on the quality of, now we're taking the approach of everything's coming off the same zero, and so it's either everything's correct or everything's off. So it's like, maybe that's a little dangerous to say, but at the same time, that's the reality of it. Hopefully, if everything is shifted by, let's say, 4 inches in the entire building, somebody's going to catch that pretty quick and early, as opposed to a single trade having a couple of points that are off because that was, X foreman laying out on X day on that 1 week, an overtime on Saturday or something like that. So hopefully it surfaces those issues earlier, and you can get some solutions to it a lot quicker.
Hi, everyone. Great panel. Henning Rodell from Hard Hat Robotics. So, Urel and Mahir, you were saying that some jobs are a good fit and some jobs aren't. So this is a question for the whole panel. Where do robots not make sense in construction? Where are the boundaries or where are the limits?
Yeah. For example, we're just deploying the Hilti JBot on one of the projects. Where it might not make sense is if you're just drilling a few holes. You don't have as adequate hole density. Those are the cases where it wouldn't make ROI sense to deploy these more smarter, advanced tools. Now, in the future, if JBot becomes much more leaner, more smaller, where you can, it's like just like a few $1,000s, you can transfer it to the field, then it might again make sense. But as of the tool is right now, you have to ensure you have certain conditions met so that the ROI is justified for that tool. I want to even call it I keep going back, but I wouldn't call it a robot. Where do robots make sense or not make sense? I would call it, where does this tool make sense and where does that tool not make sense?
And maybe something to add up is, and this is something we work in the construction robotics class as well, when we do the initial feasibility assessment, it's not like a robot is always beneficial, or so it really depends on a case-by-case basis, unfortunately. So it requires some understanding of what are the parameters, where the robot performs well, and then also what is the project, where it's located, what are the specific components of the project that could make or break the application. I know for us at CIFE AI, we have set out some internal parameters where we know if the project is smaller or shorter than X amount of years, then we know it doesn't even make sense, so we won't even waste someone's time. But defining all of those parameters and making sure you do like a thorough analysis of the project before embarking on it is very helpful.
Yeah, I think we also have to define essentially what does make sense mean, right? Essentially, if you start by saying, commercially speaking, does it make sense to deploy a robotic machine to do something that a human may actually be doing it significantly faster, or without necessarily adopting the technology or anything like that? Part of it makes sense also could be on the method, right? So for example, if a robot, in order to operate, needs to work in a BIM environment, and the company isn't currently fully into BIM and doesn't have the input data, that is a limitation in itself. Part of it is, the space requirements or the capability of the tool, and therefore there are some tasks that are just, like he was saying earlier, it just doesn't make sense in that particular instance. I think as a manufacturer, what we try to do is we try to focus on what are those tasks that are the most repetitive, right? Therefore predictable. Therefore there is essentially economies of scale of doing it in a repetitive manner. What are those tasks that are perhaps too risky or too unsafe for humans to perform? And we're trying to essentially define what are the low-hanging fruit for us to be able to develop technology. At some point, fast forward, 20 years from now, the likelihood is that tasks that we didn't ever even think that were, possible or fathomable for a human to, or for a robot to do, I think we'll get there step by step. But we have to start with those tasks that are the most, like I said, repetitive or the riskiest ones for us to focus as low-hanging fruits.
Yeah, and there's also just obviously the physical limitations as well of whatever system you're using. A lot of them, if they're using total stations, it's via line of sight. So maybe you do have a pretty decent-sized project, but it's a whole bunch of very segmented, compartmentalized rooms. Doesn't quite make sense compared to like an open warehouse situation. So really knowing the site as well, sometimes you gotta see not just the plans for what you're building, but also see the actual on-site conditions as well. So that's where some of those logistics come into play. And then also, let's say talking to your project team, your superintendent who might be scheduling out and sequencing things, again, you've got to get all of your points and plans in together, coordinated and we'll say done before it gets laid out. And with the way that the project is sequenced, does that actually work? Can you get everything modeled and coordinated at the same time, or are some of these trades locked in, but these other trades aren't required to be locked in until further down the road? Are you making multiple visits instead of doing a single pass? So again, kind of evaluating, a single visit all at once can make time and financial sense, but 3 separate visits, does it still make sense? So again, the logistics of the site itself.
I'll just add, when it comes to, for example, the JBot we're deploying on a project in Washington, to his point on physical limitations. The JBot has maximum reach of 16 feet. So the basement on that project is it 12 or 16? 16. So that project basement is about 16 feet. That's where we're using it. But all the top floors are more than 16, so that's where we are not using it. Also, upper floors have post-tension bars, so we are more careful. But it can be in a particular zone of a project, you can still use some of the tools.
So due to the time limit, we can only take one more questions.
Yeah. So first of all, you might notice we're running a little late, students, for the company intros. We will start shortly. There is couple more people that are trying to get slides to me, I think. It has to happen like pretty much now, just to say that. Okay, the question I have, you talked a lot about technical feasibility and various side conditions, etc. What about the business side? You haven't really talked much about the business models that you have found useful. Is it because everybody has now gravitated to the same business model that you're getting robot from? It's not what I heard, but I'm just curious what your experience is in terms of business models that work or don't work from your perspective.
Yeah, I think that's a great question. Especially for a GC, a lot of medium, small GCs, it's very cost prohibitive to get these very expensive tools. So can the solution providers offer different like business models? For example, instead of us purchasing the spot and the different kind of the autonomy pieces, can there be a solution provider that offers it as a service at a rental? That's where Field AI comes in. They offer autonomous reality capture as a service. They have the spot and their autonomy unit. They'll come to your job site. They'll do the capture for you with their technicians. At the end of the day, they'll take the robot back to their office. And all you get is the raw sensor data. I think that's how you can be creative as well.
All right, thank you all for your participation, and also thanks again for the panelists. So that brings us to the end of the panel, and now we'll take a 10 minutes break.